Hi, this is Dan Kalish, and welcome to our workshop on addressing cardiometabolic health by restoring mitochondrial function. Notice the pause, deep breath there. We're talking about oxygen and mitochondria and stuff. So I'm super excited to be here. I've been working on this for a couple of years, and it's the most exciting thing I've done professionally that I can remember. This is great. And we're having a great support here from Genova Diagnostics Lab. So I want to thank them profusely for helping us get the word out to their audience as well. And I am all about lab interpretation and patient communication skills development. That's kind of been the focus of my career. And so I want to welcome you. If you're new to this, I will introduce myself, new to us, here, I'll introduce myself a little bit, talk a little bit about the class, and then we're going to jump in, okay? So I have been in practice for a really long time. It says over 25 years now. That's because it's been almost 30 years. I'm 57 years old. I don't know how that happened. Anyways, I've been doing functional medicine for a really, really long time, and I love it more now this week than I did 10 years or 20 years ago or 30 years ago. It's a great profession. It's a great field. And so if you're new to this industry, you're new to this field, it's great. This is like a lifetime of really just a great job. I've had in the last few years a bunch of great experiences. I worked with the Mayo Clinic on a research project looking at the clinical work that I do in my practice. We analyzed that. We actually published a research study with Mayo. If you guys are curious about it, you can email my office. I'll send you a copy of the study. It's not about cardiometabolic stuff. It's about adrenal and GI problems. And I'm working with Richard Lord now, one of the top scientists in our field, to bring you guys the latest and greatest in all the research. And I've been in practice for a really long time of actually doing this work with patients all the time, not every day, but 2 days a week on a pretty consistent basis, all these years. So, and then a little bit about Kalish Institute. So the whole point of the Kalish Institute is that we're really focused on figuring out what are the roadblocks to people building practices. What are the roadblocks to people scaling up and making their practice widely available to as many people as possible, right? And there's so many different like business logistical issues or clinical lab interpretation issues or patient communication issues that show up. And I've worked to develop courses over the last 20 years to try to address each of these. And we have right now a boot camp series that we're releasing, including this one that's coming up now, like today, like yesterday. This is the first time we've ever taught this course. Okay, it's a cardiometabolic boot camp. What you're going to learn today is just a little taste of this, maybe 30 or 40 minutes of what is a several month experience. And so the class is starting this week. If you're interested, you can still sign up. We did have an orientation call yesterday, which you can listen to, 45-minute call. It's just a kind of nice to get to know you kind of call. So you're not behind at all if you want to start the boot camp this week. And we saved 5 seats for Genova referrals, and you get a 20% discount if you use this special Genova code. It's not too hard. It's GD21 for Genova Diagnostics 21. And that knocks a whole bunch of money off the course fees and makes it even more affordable. If you're thinking about doing it and you're a Genova customer, then please sign up and use that code, and you can get into the class and jump right in. It's a pretty extensive class. It's only a couple months long, but it's a lot of material in there, getting deep, deep into the weeds on lab interpretation and patient communication skills, right? So that's what we've got going on right now at Kalish Institute. And then I have my mentorship class, which is, we start several times a year. We talk about that later. But I wanted to get right to the subject at hand, which is looking at cardiometabolic health and mitochondrial health from a clinical nutrition perspective and from a lab interpretation perspective. And so we'll go through these slides and present, the basic information, and then we're going to save the second portion of tonight for lab review. So you can see how this really plays out with a bunch of tests. Thinking also about how mitochondria make energy. This is more important now than ever with what's going on health-wise throughout the world, right? And what are the key nutrients that we can use to restore mitochondrial health? Like, you should just know these off the top of your head. You should be able to glance at one of these labs and go, yeah, CoQ10, no. Magnesium, yeah. Carnitine, maybe. B vitamins, for sure. Next lab, CoQ10, magnesium, carnitine, oh my gosh, B vitamins, triple the normal dose. You should just be able to do that, like that. You should be able to just glance at a lab and do that. And that's kind of the the skill set that you should achieve, because this stuff really makes a huge difference for patients, and it's not kind of optional. I mean, it's not a nice thing to have, like mitochondrial health. You know, it's like, I don't know, I'm kind of a little obsessed with cars maybe, but I've been shopping for an Alfa Romeo QV lately. If you guys appreciate cars, you know, it's probably the fastest four-door sedan that's ever been built. And it's a really beautiful Alfa Romeo, but okay, they break down constantly, but that's a whole different issue. But you know, when you're really getting focused on something and you're like in the weeds on a subject and you're really wanting to understand a subject, it's very easy to lose perspective on the bigger picture of what's really happening, right? And with a car, for example, there's a lot of different things. Like some of the models have these carbon fiber seats that are like a $3,000 upgrade, but they're really beautiful. And some of the cars have like carbon fiber roofs. There's a whole variety of different things. And you could either get those or not, but the thing will still work. But like I wouldn't buy one of these if it didn't have wheels and tires on it, because then it wouldn't move forward, right? So the mitochondria, they're not like a peripheral subject that only affects certain segment of the patient population that you're working with. It's not like getting a nicer radio and better speakers in a car, right? The mitochondria is just like fundamental. They're usually called the engine of the cell, but this is called like the wheels and tires of the car, right? They're like literally nothing goes forward in your body, your brain, your heart, your liver, nothing can work unless you have sufficient ATP. So this is not like a nice to have, oh, maybe I'll get that model that has this. No, this is like essential for every single patient that you're working with. Now we're focusing a lot on cardiometabolic health, so that people with diabetes, pre-diabetes, history of cardiovascular disease, maybe they're obese, but really this affects every single patient that you're working with that's fatigued, every single patient that you're working with that's depressed. I mean, honestly, even every single patient that you're working with that has a gut problem, you got to at least check and restore their mitochondrial health in order to get them healthy, right? So it seems like an obscure topic, but it covers every single organ system, tissue, and cell in the body. And so as we're looking at this, you just want to keep that in mind, because a lot of this talk is oriented more around fats and metabolism and stuff. But this is the most important thing you could do for a depressed patient, right, is to make sure the mitochondria are working. So it has applications outside of the narrow little subject that we're talking about today. So I want to also talk about production and utilization of CoQ10 and the electron transport chain and how those can get screwed up. Once you see the pathways, this all starts to make a lot more sense, okay? So now, one of the first things that Dr. Lord had me do when we first started to work together was he's like, okay, where does this all really start? Let's talk about electrons and orbitals. And I was thinking, oh my gosh, this is like, my second year of college and my fourth year of high school. I got orbitals. What are we even talking about? But it does help from a clinical perspective to understand that what we're actually doing here is just watching electrons move around, okay? And we're watching carriers carry them to certain special places. So for example, NAD, NADH, passing on electrons. CoQ10, grabbing an electron, moving it over there, grabbing an electron, moving it over there. Okay, magnesium even is really involved in this whole kind of coalescence of each of these steps, and then the final steps of cellular energy production, which again is just shifting electrons, then protons move. Okay, if this system's not working, it's what we define as cellular aging, it's what we define as metabolic disruption. The latest studies that get cited all the time now are 88% of Americans have a metabolic disorder. So this is a pretty big problem nationwide, right? So at the highest level, we just talk about oxygen and glucose and fatty acids. And here we go. Oxygen, that's our breathing, right? 90% of the oxygen you breathe goes into mitochondrial energy production. Glucose, that would be the foods that you're eating. And then fatty acids, again, the foods that you're eating. Okay, those are all the input. And then the output is what? Water and carbon dioxide. Okay, that's what we end up making here, the equations here, water and carbon dioxide. Now, this may look familiar because, again, if you're back to maybe 9th or 10th grade biology, you're like, wait a minute, is that photosynthesis in reverse? And you'd be right. So if you were a plant, let's say a plant, we'll put P for plant, you would be using water right? Through your roots and sucking in carbon dioxide through those little pores that plants have. How they do this, I don't know. It's just every plant has to do this. So they're pulling in carbon dioxide and water, and then they're storing glucose, right? So we come along, eat the plant, or we eat an animal that ate plants, and we're taking on that glucose. So there's this whole kind of amazing cycle that starts with plants and photosynthesis and then ends up with our body getting these same electrons. They're not different electrons, they're the same electrons flowing through us and then going back into carbon dioxide and water, which happens to be the stuff that plants need. It's this beautiful cycle, right? And we're just in the middle of it. We're just like dealing with these electrons passing through. And what we want to see is how well is that system working? Okay, we know plants work pretty efficiently, but how well is this human body in front of you processing electrons through energy production? That's the bigger question. You make around 30, 34, 38, depending on who you read, somewhere in the 30s, ATP units per unit of carbohydrate. You make over 100 units of ATP per fatty acid molecule, which should be a clue right away there that fat is very important for energy production. And then, okay, there's the how the thing works part, which is how the mitochondria work. We'll look at a bunch of slides on that. But then there's I've never had a patient who came in whose mitochondria are working perfectly, or maybe a couple a year, but it's rare, right? Almost everybody that comes in has got some kind of a problem with metabolism somewhere, or they wouldn't be seeing you. So what we're then worried about is like, well, how could this system get messed up? What could happen to it that would be bad? And the major sort of punchline for that is some kind of oxidative stress damages mitochondria, damages the enzymes that are working the mitochondria, damages the system. So then we wonder, okay, where's the major source of oxidative stress or reactive oxygen species? It's actually from mitochondrial energy production itself. The external sources then that we're worried about would be environmental toxins. So we've got internally generated free radicals from our own production of energy, and then external sources which could come in the form of toxic heavy metals, chemicals, et cetera, et cetera. Too many of these free radicals altogether damage blood vessels, excessive oxidative stress, the LDLs become oxidized, and then your arterial plaque starts to develop, and then you're off and running with a really big problem. Okay, now there's a solution to this problem. So there's a problem of oxygen, of not enough antioxidants to protect ourselves, right? And the free radicals just damaging things. And then there's a protection that's offered by glutathione and other antioxidants. And so we're going to look at all that when we look at the labs. So again, we're going to look at mitochondrial function. Are the mitochondria working or not? Are there enough of them present? We can look at oxidative stress. Is there a lot of oxidative stress that would be damaging the mitochondria? And then how can we reduce or eliminate the oxidative stress to protect the mitochondria? And how can we get the nutrients that are required by the mitochondria to start to work? Okay. But just as there's no way that you would purchase a car without wheels and tires, there's no way that you would want to work on a patient unless you knew their mitochondria were in tip-top shape, okay? So here's what they look like. They have an outer membrane and an inner membrane, and some of this ends up being important. There's this whole interesting story about mitochondrial DNA, which we don't need to get into, but they're all from your mom, Your dad has nothing to do with your mitochondria. I know it's a little strange, but that's the way it works. And then here's a quick refresher on the subject. We take glucose molecules, we break them down into pyruvic acid. This is measured on the test, okay? Pyruvic acid. We then convert them pyruvic acid into acetyl-CoA, and we go through the citric acid cycle, and we're measuring all these steps of the citric acid cycle. The electron transport chain then finalizes this energy production, and we make energy inside the cells. That's the gist of it. It's a very simplified diagram. I've got a bunch of these so you can see. What we're concerned about is when the healthy mitochondria shown at the top here, of which you can have thousands and thousands in an individual cell, becomes damaged. And then the energy production is reduced, and then you could have a metabolic issue, a brain issue, an anything issue. I like to talk to patients about mitochondria in relation to breathing because everybody knows that when you hold your breath, things get kind of hard. And it just kind of gives them a reality check on how important mitochondria are, right? So they're the electron receptor from the electron transport chain. They're ultimately what's making things work in terms of our breathing. And then also, from a very big picture point of view, we're talking about glutathione protecting our mitochondria. if we have excessive oxidative stress, then glutathione levels will drop. And we can measure this, and I'll show you on the testing. You can measure the amino acids that are involved in this whole process, like cysteine, okay, taurine. You can also measure glutamine is another one, glycine is another one. You can also measure sulfation or sulfate, okay, and you can measure pyroglutamate. There's a whole variety of ways that you can assess glutathione status. And if glutathione status is not great, then the mitochondria are highly susceptible to becoming damaged. Okay, so again, I'll say that if glutathione levels are not very good, then the mitochondria are very susceptible to becoming damaged and not working well. And then we have this other process that has become famous in the last few years called methylation. And methylation constantly competes with glutathione production. So glutathione and methylation are intimately linked. If you have a methylation problem, pretty much by definition, you have some level of a glutathione problem. If you have a glutathione problem, kind of by definition, you have some level of a methylation problem. They're directly linked and are in fact moment to moment adjusting one another based on the other. So in other words, if you have a lot of oxidative stress, methylation will decrease. See the decrease there? And transsulfuration and production of glutathione will increase. If there's a moment where there's less oxidative stress, then the opposite happens, but they're directly connected. They're impacting one another moment to moment. And the cool thing is you can measure all this stuff. I mean, it's like the first time that you see lipid peroxides, this just happened to me the other day for like the 100th time, but when you see lipid peroxides coming back really high in a person, and you know that they're super high risk for cardiovascular disease and cell membrane damage and all kinds of other things, and then you give them like a bunch of CoQ10 for 6 months, and then they retest, and you just see that number drop, and you're like, well, how are you doing, Susie? And she's like, I don't know. I feel great. My energy is better. My sleep is better. My cholesterol levels are better. Everything. I don't know what we're doing here, but is the diet and these supplements really? Yeah. Okay, you can actually measure this and track it, and people will experience the benefits as well. You'll be able to see it live in person. It's very exciting to do that. And I always say this in class, in my mentorship class, is the second test you do, the second NutriVal, is 1,000 times more interesting than the first one. So if you guys are testing and you're doing a NutriVal, don't deprive yourself of the joy and excitement of waiting for 6 months after they're on a good program, diet and lifestyle and supplement program, and then retesting, because the retesting is really where you see the magic happen. Okay, it's much more interesting than the first test. So we can also measure CoQ10 and magnesium and fatty acids and amino acids, oxidative stress, all these things are on the tests. Organic acids, we can look at every little step that we're talking about. And we're just going to focus on a few things today because we don't have a ton of time. But I want to at least briefly touch on CoQ10, magnesium, B vitamins, and carnitine. That's a lot right there, okay? So we already said this, primary source of oxidative stress is the mitochondria, making energy. And now this is a nice little breakdown of what we're going to investigate as we look at some of these labs. So a few things that you should just be able to spot. One would be a problem with fatty acid metabolism, also called beta oxidation. And then for the purposes of this class, I want you to be able to see citric acid cycle problems inside the mitochondria, okay? Inside the mitochondria. So a lot of times these things are differentiated between where they happen. So just as a clue here, glycolysis, or the metabolism of carbohydrates, that starts in the cytosol, outside the mitochondria. Starts there, right? And that's where pyruvate is made. Beta oxidation, the burning of fat, happens within the mitochondria, and the citric acid cycle happens within the mitochondria, and the electron transport chain happens within the mitochondria. Okay, and so we have some pictures on that so you can see. It matters because you want to know if it's a mitochondrial problem or not. And then when you're actually looking at the lab reports, here are the markers that we're going to focus on. So you want to see within the citric acid cycle itself, what's happening with citrate, cisaconate, isocitrate, alpha-ketoglutarate, succinyl-CoA, succinate, fumarate, malate, okay, all these. So now, because it would take probably a year or two to study each one of these in detail, I like to focus on just a few of them so you can get a sense of what we're talking about. And my favorite one to focus on is succinate. Okay, and there's an enzyme appropriately named succinate dehydrogenase that converts succinate to fumarate. Okay, and so if you see problems with succinate, you know that it's this enzyme that's not working right. It's a very specific test. Similarly, I don't know, let's say if you see a problem with this building up, then you know that the alpha ketoglutarate dehydrogenase enzyme is not working well. And this can really matter. In the last year, I've had 2 or 3 patients whose main health problem was that their alpha ketoglutarate dehydrogenase enzyme was all busted up and didn't work at all. And so their alpha ketoglutarate was sky high. Look it up. It's actually a real thing. It's like a real medical problem. You know, no one probably have never even heard of it before, but you know, I've had it 2 or 3 times in my practice this year. You've probably had a few cases of it over the point. You know, it just happens. And once you know how to handle it, it's easy to handle. And it's a potentially nutritional solution. There's no drug to fix that anyways, right? So we're going to look at all these different enzymes and start to think about them. And then here you can also see the citric acid cycle combined with the electron transport chain. So here we have our glucose and our fatty acids coming in for energy. Beta oxidation is happening within the mitochondria, okay? The citric acid cycle is happening within the mitochondria, and then the electron transport chain is in the inner mitochondrial membrane. And these are the key things that we want to track. Now, everybody knows and has studied a lot about glucose. So we're going to de-emphasize that because we're assuming that you know about insulin resistance, high insulin levels, problems with glycolysis, because people talk about that a lot. So I'm going to talk a little bit more today about fatty acids and how fatty acids are broken down. And remember, the fatty acid, you can see the arrow, comes into the mitochondria. This area down here, see here's the outer membrane of the mitochondria, here's the inner membrane. So beta oxidation, the burning of fat, happens within the mitochondria, and so does the citric acid cycle itself. So if you see markers like pyruvic acid or adipic acid that are related to beta oxidation, that's a mitochondrial problem that's happening inside the mitochondria. If you see problems with malate, fumarate, succinate, any of these, alpha ketoglutarate, that's happening within the mitochondria. And if you see problems with CoQ10 and the electron transport chain, that's happening in the mitochondrial inner membrane. Okay, so now we're solidly in the mitochondria. That's a physical location for what we're talking about. We're measuring all these things inside the mitochondria. It turns out CoQ10 is extra important for a gazillion reasons. This diagram is like everything from your head to your toes. CoQ10 really matters. And I just want to show you a little bit about what it looks like so you can see it. I don't know, for me, when I can visualize things, it just makes it so different. So this is a CoQ10 molecule. It's 50 carbons long. It's got 5 carbon isoprene units, but it's got 10 of them. So 10 times 5 is 50. It's 50 carbons long. This thing is massive. It's like it's more of a fatty acid than any of the fatty acids. I mean, most of the fatty acids we talk about are like 16 carbons long, right? This thing is like 3 times longer than that. It's crazy how big it is. And then this end here is the redox active head group. That's the thing that's really good at grabbing and moving electrons. Grab electron, move it, grab it, move it, grab it, move it. Okay. And there's nothing else that does this. It's not like there's a CoQ3 or something. It's not like, oh, it's like Audi cars, you know, like they have the Q5 and the Q7 and the Q8. I really think the new Q8 is pretty nice, but there's just CoQ10 human body. It's just Q10, that's it. So if you don't have enough CoQ10, there's not like another thing that steps in and does kind of a crappy job at moving electrons. It's either this or nothing, okay? And so this is what's running the electron transport chain. This is the molecule that's transporting the electrons. It's the chain, okay? It's grabbing them from complex 1 and 2 and throwing them over to complex 3. And if that's not there, your CoQ10 isn't present, then that's it. It's just not going to happen. I don't know. It's not really a weakness in the system. It's just sort of a thing you should know. And then here's another diagram on how CoQ10 is made. So interestingly, from acetyl-CoA, we make coenzyme Q10. From acetyl-CoA, we also make cholesterol. And from acetyl-CoA, we make this stuff called geranyl, which has to do with protein trafficking, with how we move membrane proteins around. Trafficking is a fancy word. Really, it's transport, transport, movement of the proteins. Okay, so this is how it's produced. And if you're a real biochemistry nerd or something like that, then you'll just appreciate this. Look at this, see this marker here? It's para-hydroxybenzoate. Okay, this is a marker that shows up on organic acids tests. It's a polyphenol marker. So in other words, this is the polyphenol. This is from consumption of fruits and vegetables. It's their last little step in the production of CoQ10. It's totally dependent on the person eating fruits and vegetables. That's kind of like a little fun fact for the day, Just get your patients to eat healthy food, part of the solution here. Again, here's your CoQ10 laid out in a membrane. And here's the same pathways, just a different view. You got CoQ10, cholesterol, the protein prenylation thing, all happening from acetyl-CoA. And then here's what we're talking about when we say protein prenylation. So your body takes acetyl-CoA, and it does all these different things with it. And one of the things that it does with acetyl-CoA, and I think actually the second picture is easier to see here. This one's a little easier. Is one of the things it does with all that acetyl-CoA is it crams on these little tails here. You see these little guys here? Onto proteins that are membrane bound. So when you have a protein that needs to be located in the cell membrane, this little protein prenylation process crams these tails on it so that it can locate itself into the membrane. So all those processes are quite important in terms of how this is all going to work, right? And then we're going to go on. So you see a little bit about CoQ10, how it's produced, cholesterol, how it's produced, protein prenylation. These are all, basic biochemical pathways that have to do with lipids. And then we have beta oxidation. This is how we burn this stuff up. Not how we're making things, but how we burn it up. And this is quite complicated, but you need to know this because this comes up with patients all the time. You should see this, I don't know, I see this in my practice at least 3 or 4 times a month, and I have a pretty small practice. You guys probably should see this 2 to 10 times a month, okay? So here's the cytosol. Here's the inner mitochondrial section, the matrix they call it. So your body has to get fatty acids into the mitochondrial matrix so it can burn them up for fuel. This is the main fuel supply for the human body. So when you're at rest, sitting there or sleeping or something, 80% of your energy comes from fat. When you're exercising hard, of course, you start to burn a lot of glycogen and your glucose stores and all that, changes short term. But when you're sitting around, which we do most of our days, right, you're not in extreme physical activity and you have enough oxygen coming in and out, the primary fuel supply for your heart and for the whole rest of your body is these fatty acids. So beta oxidation is the main way we supply energy for the heart, for the brain, for the skeletal muscle, unless you're exercising really hard, in which case it changes. So the main fat is palmitic acid or palmitate. We have to get this fatty acid across this membrane and across this membrane so you can break it up and turn it into energy using beta oxidation. All right? Main fuel supply for the entire human body. This is like where it comes down. Remember, this is all happening where? Inside the mitochondria. So now, at first, you have this palmitate, and it gets converted into palmitoyl-CoA. And there's a little structural glitch here, is that the palmitoyl-CoA is such a large molecule, it can't get across the membrane. Bummer. So your body strips off the CoA part and puts on a carnitine. Now we have palmitoyl carnitine, which is quite a bit smaller. You see the difference there? Here's the palmitoyl CoA, huge, won't fit. Here's the palmitoyl carnitine, small, fits really easily. So then that carnitine transporter comes through here, through an enzyme, the carnitine acetyltransferase 1. It goes across this, it goes does a nosedive through this translocase protein, and then it gets inside the mitochondrial matrix. And then your body does something that's even more incredible, is that the carnitine disassociates, it comes off and goes back out to do this again. And the palmitoyl converts back into palmitoyl-CoA, which is what it was right over here. Is that crazy? That's a lot of work. It's a highly regulated system. Now, when you see something this complicated, what are you thinking? There's lots of ways it could get screwed up, and you're right. Like this thing might not be working. This thing might not be working. This might not be working. And what if the patient doesn't have enough carnitine? If someone came to me, and this has never happened, but let's make up a good example. Let's say, because I'm a basketball fan, right? I'm a Warriors fan. So since I've been 10 years old, I love the Golden State Warriors. So let's say someone came to me and said, look, the Lakers are going to play the Warriors. And, let's just make it so that the Warriors win this game. They deserve it. It's been a long couple years, and they were the best team in the world for a long time. And now, okay, the Lakers have LeBron, and it's kind of unfair. And let's just change the odds on this. What could you do that would just completely screw up the entire Lakers team? I don't know, 20 minutes into the game, so no one suspects that they were drugged. I would say, okay, well, let's invent a drug that blocks your carnitine from working right. Let's just make sure that they all have low carnitine, because then they're not going to be able to burn fat. They're going to run through their glycogen stores in the first quarter, and then they're all going to just fall down the basketball court and, not be able to play basketball anymore. I mean, this is like really, 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 really important. And I've done this with professional athletes who are low in carnitine. It's like a career changer for them. I mean, if you're a professional cyclist and you're low in carnitine, you are not in a great place. And if your doctor gives you a boatload of carnitine because they did these labs, you are in a very good place. You're in first place, right? You go from being behind at the end of the pack to being up front. And I've done this many, many times with professional athletes. Now it works for regular people too. It works for people who are, have had or are worried about having a heart attack. It works for people who just want to lose 10 pounds. Because what we're talking about is the burning of fat for fuel. Okay, again, we convert the fatty acid into palmitoyl-CoA. We convert that into this palmitoyl-carnitine. You have to have the carnitine or the fat can't get into the cell. The carnitine transports it. In some miraculous way, the body lets go of the carnitine, it comes back out, and that palmitoyl-CoA then is broken down into energy. And here's our acetyl-CoA, which is ultimately what we're going to run through what? The citric acid cycle, the Krebs cycle, right? The acetyl-CoA. So all this work is getting this fat from outside the cytosol, in the cytosol, into the mitochondria, so we get acetyl-CoA. So just remember that. Fatty acid, a lot of work, goes to acetyl-CoA, got to have carnitine or it doesn't work. And we're testing for this, okay? I'll show you the labs that we measure so you're not wondering, is beta oxidation working? I only give carnitine to patients who have a problem with it. I don't know what happened, you just gave it to someone randomly, but if someone's low in carnitine and you give it to them, it's gonna be a significantly different process for them. And here's just a blow up of those molecules so you can see. Remember that palmitoyl-CoA can't get across the membrane. Look how big it is. It's a size problem. So your body goes, okay, we're gonna chuck the CoA out of here, CoA, cram on a carnitine, and now it fits in. But then it puts the CoA back on at the end of the whole process. And your quiz question for the day is, what does CoA stand for? I don't know if anyone knows. I'll give it like a 10-second break and you can see if anyone can type in the right answer or not. CoA is code word for vitamin B5, right? It's pantothenic acid. This is B5 here, okay? So another kind of clue, you have to have B5 for this to work, and especially you have to have B2. Okay, there's a few B vitamins that are required for all that. And if you don't want to have to memorize all the different ones, just give everybody a B complex and call it a day, okay? Because they all have all the B's in them. All right, so now, oh my gosh, let's see. We're doing pretty well on time. We have 10 minutes. All right, so I just want to do a quick review here so you can see how this works, and then we're going to look at labs in a few minutes. But there's a few other little facts to learn. So long chain fatty acids, that's what we've been talking about. Here's our carnitine, here's our transporter, and that fat is now getting into the mitochondrial matrix. It's getting eventually converted into acetyl-CoA, which we talked about, and then we're running beta oxidation on it, and we're making energy, right? Now, what's just an interesting little thing is that's long chain fatty acids. Medium and short chain fatty acids, they're small. Zoop, they just go right in. None of this fancy transporter thing. That's why a lot of people recommend them. It gets around the whole carnitine problem. However, almost the vast majority of the fat that you're burning is long chain fatty acids. So you can't just like, live on your short and medium chain fat. So you've got to get this process working or it's life threatening. But just a little thing you should know that the medium and short chain fatty acids get in a different way. Now, once that fatty acid is entered into the mitochondria, you have this other structure called the mitochondrial trifunctional protein that's working. And here's what it looks like. It's pretty cool. This is a graphic image of all the amino acids that fold up into this trifunctional protein. It's a crazy looking thing, isn't it? It's complicated. It's beautiful. Okay, and what does that actually do? Well, here's our carnitine and our long chain fatty acid. Here's our medium and short chains. All these end up eventually getting into the mitochondria. And we run this trifunctional protein, spins them around and dumps 2 carbons off at a time, spins it around, dumps off 2 carbons. It's dumping off acetyl-CoA groups, right? Acetyl groups, just breaking down the fat. So if it's an 18 carbon fat, whoosh, you spin it around, 2 carbons disappear, now it's a 16, you spin around, now it's a 14, you spin around. You're just breaking this thing down. That's the process of beta oxidation. And then at the end of the day, you end up with all this acetyl-CoA. Right? And just to bring you back a moment ago, the acetyl-CoA, let me just show you here. I'm going to skip back a few slides. I'm going to tie this together for you. The acetyl-CoA that we're talking about is this acetyl-CoA here. It's the acetyl-CoA that you're using to make energy. That's the acetyl-CoA that we're talking about. Right? It's also the acetyl-CoA that we were talking about way earlier. It's the same acetyl-CoA, right? There's not like there's different kinds of acetyl-CoA. It's the acetyl-CoA that's used for cholesterol production, CoQ10 production, protein prenylation, all those things. It's all acetyl-CoA. Where's that one? Sorry, I'm skipping around the wrong way here. Here, this one. It's the same acetyl-CoA. See the acetyl-CoA at the bottom here? That's how we make cholesterol, CoQ10, and we go through this protein prenylation process. Same acetyl-CoA. The problem gets to be when there's too many calories, there's too many carbs, there's too much fat, the person's just overeating, and then there's too much acetyl-CoA. Then all of this goes bad, right? Because you can't burn it quickly enough. And then you store it. If you can't burn the energy quickly, you've eaten too much, especially too much carbohydrate, you're going to store it immediately as fat. Okay. However, if this process is not working, even if a person's eating well, it's not going to work. They're not going to make the right amount of ATP. So it's another view of the same thing. Again, it's the carnitine pulling the fatty acid in, and then the making a formation of acetyl-CoA. But just to tie this off for you one more time, this is the acetyl-CoA that then enters the citric acid cycle, right? It goes off and makes energy, or you could eventually have it making cholesterol. It can get out of the mitochondria. That's a whole nother story, probably don't have to talk about. You can also use the acetyl-CoA to make CoQ10, and you can use the acetyl-CoA for this protein prenylation process, which is how we move proteins around so that they get into cell membranes. Lots of things acetyl-CoA can do. Now, if you want to get all negative and think about the dark side, if there's too much acetyl-CoA, then we have too much cholesterol, and that can cause a heart attack. If we have too much acetyl-CoA, we can have too many triglycerides, too much fat, you could have fatty liver. If we have too much acetyl-CoA, you can end up with the mitochondria not working well, right? The whole system's kind of gummed up. There's too much acetyl-CoA for the body to process. And then what happens? We become insulin resistant, right? We could call that syndrome X, metabolic syndrome, whatever you want to call that. So if this process is not working smoothly, then all those kinds of problems start to happen. Okay, and then here's the final part of this whole thing, and then we're going to look at labs. So the final part of this whole thing is that after all this work, you've got all these electrons that you've been moving around. And then finally what happens is we get to the electron transport chain, and there's complexes 1, 2, 3, 4, and 5. And the point of the electron transport chain, you can see here, we have these protons that are getting pumped over this way. See how there's all these H pluses here, all these protons this way? So that movement of electrons is fueling or energizing the flow of protons. And when there's all these protons here, eventually there's so many of them here, they start to come back down across this gradient here. And that's how we turn ADP into ATP. So the electrons force the movement of the protons come back, and that spins this water wheel looking like thing that's called ATP synthase, and then we start to make ATP. Okay, so that's the final step of the process. Now I want to show you all these things on the labs. Like, for example, we're going to look at CoQ10 levels. If CoQ10 is low, everything on this diagram is going to fall apart. If magnesium is low, everything on this diagram is going to fall apart. If the person is low in oxygen, they're not breathing sufficiently, they're shallow breathing, or they have something that's blocking their breathing passageways, then it's not going to work. If they have a problem with my current favorite enzyme, my old favorite enzyme was pyruvate dehydrogenase, honestly, but this last couple months, succinate dehydrogenase, I find way more interesting. So my favorite enzyme, if that's messed up, this whole thing's not going to work right, okay? All right, so let's do a quick little wrap up and then look at labs. So number one, mitochondria sustain damage from a variety of sources. That's oxidative stress we talked about in the very beginning. Once they're damaged, they don't make enough ATP. And we went through all the different steps of like how you make the CoQ10, how you make cholesterol, how you burn these different fats, the long chains and the medium chains, how the citric acid cycle actually works, and how the electron transport chain actually works. So if you can picture all that and picture part of that not working, and next time you see a patient that comes in that just says, I don't know what's happening, but I just walk up a flight of stairs and I have to sit down because I can't catch my breath. You're probably thinking, I wonder what's happening with your mitochondria. Or maybe they have had a recent heart attack and you're thinking, wow, you're covered on the medical intervention and we got that dealt with. You're on the right medications, but maybe we should really look at why this happened in the first place. And in addition to working with your cholesterol with a statin, let's think about what we could do to change your metabolic function, period, to make this whole thing better from the deepest level, right? It could be weight gain, it could be depression, it could be any of these things. Okay, so I'm going to take a sip of water and then think about things for a second. So this is what we got coming up. It's starting this week. If you joined us late, we have a cardiometabolic health boot camp that's starting this week. You guys are welcome to join. You get a 20% discount if you're a Genova Diagnostics customer, GD21. And we're saving 5 seats for you guys who are listening to these talks. So it's not too late to register. You can still sign up. We did the orientation call last night. It was a high get to know you call. If you sign up, I think tomorrow's the deadline. The end of the week is the deadline. If you sign up sometime tomorrow, you can still get in. You get access to everything. You're not behind at all. Just listen to the orientation call and you can jump in and spend a couple months really looking at this stuff in depth, all right? It's a deep dive into what we're talking about tonight. Okay, now here comes the fun part. Now we're going to look at some case studies, real patients, real time here, and design some programs, all right? So with all the information that we've been gathering here and really starting to understand the citric acid cycle, the electron transport chain, how all these things are made, now this is a cutout from a NutriVal test from Genova, and they have all the raw data presented throughout the lab. They have the summary page. I just wanted to show this page to emphasize how this ties back in with the physiology and biochemistry that we're studying. So for this particular patient, when we're looking at these, clearly if the marker is in green, it's good. If it's in yellow, it's elevated. If it's red, circled in red, then you got a major problem, all right? And so for each individual patient, we want to think through how a program would look and what's actually going on. So for this particular patient, we can see beta oxidation, the burning of fatty acids. Adipic acid is okay, but suberik is not. So if that marker goes high, This whole concept of beta oxidation is being compromised. You're not able to make acetyl-CoA adequately from fat. Fatty acids are the major fuel supply for the human body. So does that fat, those fatty acids just disappear? No, they just go out and do other bad things, right? Because you want to be using them for energy, but an excess of fatty acids that cannot be used for energy are just going to cause trouble. Just going to cause trouble. As one of my friends once said, in regards to when my son was a teenager. I mean, he's in his 20s now, but I just remember this. My friend said, "Nothing good happens after 11 p.m. Don't let your kids stay out really late. Nothing good can happen. Okay, if beta oxidation is not working well." This person also has a carbohydrate metabolism problem. You can see pyruvic acid is also elevated. So that means glycolysis is somewhat compromised and beta oxidation is compromised. That means energy production is going to be compromised. So right off the bat, before we even get to the citric acid cycle, just with these entryway pathways, we've got problems. Okay. And so the treatment solutions then, you can use magnesium for what? Magnesium for everything, right? So magnesium helps burn fatty acids, magnesium helps burn carbohydrates, magnesium's required for the citric acid cycle, magnesium's extra required for the electron transport chain. So magnesium is just a given. You're going to supplement with magnesium if any of these markers are problematic. Any of the things that we're talking about in any of these classes, magnesium is just a given. But then also specifically to help with beta oxidation, we use vitamin B2, also known as riboflavin, and carnitine, a very important nutrient called carnitine. Now, in order to get pyruvic acid to flow better, right, we want the pyruvic acid not to build up, but to flow into acetyl-CoA, which means that we're burning up our glucose or sugar effectively. And again, if that's not happening, there's a block here, right? That is, by definition, the beginning of insulin resistance, metabolic syndrome, syndrome X, high insulin levels, whatever you want to call it. It's the beginning of that problem, right? And again, same thing, nothing good happens after 11 p.m., right? Nothing good happens when pyruvic acid builds up. That's just a disaster in terms of blood sugar regulation, insulin regulation, all that. Okay, so then in order to get this working, we use the B vitamins also, conveniently, B1, B2, B3, B5, and lipoic acid. B1, thiamine, B2, riboflavin, B3, niacin, B5, pantothenic acid, and lipoic acid. We'll get that pyruvate dehydrogenase complex working again, whereas B2 and carnitine will get the beta oxidation process working again. These are the most important things you can do for the human body. If you cannot make energy, you cannot, carry on your life adequately, right? This is really important. Now, once we get into the citric acid cycle, then this patient has high citrate, high isocitrate, high succinate, high malate. Okay, so there's too many things wrong there. I mean, you can't give a bottle for everything. So usually what happens with the citric acid cycle problems, if there's multiples like that, is you can use a combination product. And every company has one. It's MitoBoost, MitoVive, Mito this, Mito that, Mito Supreme, Mito whatever, right? It'll be a combination product. And I think of them as multivitamins for the mitochondria. And yes, you can use those multivitamins, excuse me, for the mitochondrial type products, even if the person's on a multi, okay? In general, they're kind of designed to stack on top of a multi. And then if you look down here, lipid peroxides are normal, so I don't have anything to worry about there. And we don't see any problems on the face of it with CoQ10 in the green there. The oxidative stress markers, 8-OHTG and glutathione, okay? So then this patient program, we're going to emphasize a little program design for a moment here. Let me just show you what a program might look like. You would want to use B complex. This is keep it simple, right? Because this person needed B2, B3, B1, B everything. So just B complex, either one a day is sort of typical. I hardly ever give 2 a day. You might want to if you really needed to. Carnitine, and carnitine is usually sold as L-carnitine. Sometimes if you want to get fancy, acetyl L-carnitine, that's typically going to be 2,500 to maximum 5,000 milligrams daily and divided, right? Half in the morning, half at night, somewhere in that range. Most people stay in the lower end of that range. And then we said they need lipoic acid. Those usually come in 300 milligram pills. So a typical dose there is 300 milligrams 2 times a day. And then you want your multi for the mitochondria, right? Whatever your favorite product is, depending on what your company that you're using. It's a combination mitochondrial product, and they're very similar. If you look company to company, they're all going to have very similar things in there. And then some kind of a multivitamin in and of itself. And depending on what multi you're using, you may or may not have enough magnesium. You may have enough magnesium by the time you've got your your mito combination product and the multi. There might be enough magnesium in there. If not, you can add some extra. Most people would be around 400 milligrams daily of magnesium. You could use a little more if you wanted to, but that'd be kind of standard. Okay, so now we've got improvement in glycolysis, improvement in beta oxidation, and improvement in the citric acid cycle. It's going to make a difference, right? It has to, in terms of improving metabolic health, right? So let's look at the next one here. Okay, again, we have a NutriVal, and again, you're going to see the summary page. You'll see the individual markers. We're just breaking out the portion of the lab that's related to what we're talking about for today. And you can see, and now the two markers for beta oxidation are both high in the red. Red is extra bad. So now you know this whole process of the ability to burn fat is compromised. You could just stop right there. Just take a deep breath and work on that for the next couple of years for that patient. They gotta get their fat burning working. They have to exercise in a specific way to burn fat. If you're running 5 miles a day at a 7-minute mile pace, you know, you're gonna never burn fat when you're exercising, right? So a lot of people think, oh, I'm going to get my fat burning going. Well, I'm just going to run really hard every day. Well, no, that's going to burn glycogen and glucose, right? And it's going to throw you into making all this lactic acid and other stuff. That's not going to help. So you got to get people into what we call zone 2 exercises so that they can actually burn fat properly. And you have to use exercise, diet, and supplements to stimulate beta oxidation. So if this person with the high adipic and supric acids were to exercise super hard all the time, they're not going to burn fat very efficiently. Number one, because there's a metabolic block that we're looking at right here, and number two, because it's the wrong kind of exercise, right? So in order to stimulate fat burning, you have to be in zone 2, and that's generally considered relatively light aerobic exercise. Of course, you can do strength training as well, and you should, because strength training will help you build up the muscle tissue so you have more mitochondria, right, to work because you have more muscles, and there's thousands of mitochondria per muscle cell. But you also want the lifestyle recommendation to be an easier form of exercise. If they want to do high intensity exercise, maybe a little bit of that each week, but the bulk of the exercise you want to use to direct the stimulation of beta oxidation or fat burning. And we only burn fat for fuel at certain heart rates, right? You push it too high, it's not going to work. This particular person, glycolysis is working beautifully. So you don't have to worry about it. It's a whole area you can just skip, right? And then within the citric acid cycle, you can see there's a little bit going on with malic acid. And then down here we have alarm bells going off. Lipid peroxides are in the yellow. That's not good. That means the lipids, like the cell membranes, the LDLs, right? The lipids are getting oxidized or damaged. And so you want to be really careful then, and you make sure that you get them some fat-soluble antioxidants, to make that problem dramatically better. Okay, so again, we have a little bit of a problem with the citric acid cycle, a big problem with fat metabolism, and then a problem in the yellow zone, right? A mid-level problem with lipid peroxides. So let's look at a program for that. All right, so now we're going to emphasize and start with carnitine because this person had a major problem with the pathways related to fatty acid metabolism. So you might want to, again, you've got this range, you might want to give them 3,000, 4,000 milligrams a day of carnitine. 5,000 is at the high end of the range. But again, they had a major problem. Remember the last person had one marker in the yellow. This person has two markers in the red. So it would warrant, a higher dose potentially, somewhere in that range. and that's to improve beta oxidation. And then we have our same B vitamin problem here, right? So you want to use B complex, which will have the B2 in it. And then you don't have to use lipoic acid necessarily. The glycolysis functions were working pretty well. You had a little bit, there's one problem with citric acid, with the citric acid cycle, so you could use the multi combo, for the mitochondria. Maybe, yeah, I would use it. Probably it'll help. Not as important as it was with the last person because they had many of those citric acid cycle markers positive. And then the thing that was different with this person is they had lipid peroxides high, right? So you have to use fat-soluble antioxidants, and there are so many to choose from. You can look at the lab to get more details. You may have your favorite. There's vitamin E, there's beta carotene, you have CoQ10, you have a whole bunch to choose from. And often I'll use a combination antioxidant product, right? To hit a whole variety of the different antioxidants to knock those lipid peroxides down. So you're lowering the oxidative stress, you're cranking up beta oxidation, and then as always, supplying some magnesium, right, with a multivitamin. So you're somewhere in the ballpark of 400 or a little bit more, maybe 600 milligrams of magnesium a day, okay? And that would be case number 2. All right, and here's our third case. And I know there's a little redundancy here, repetitiveness, but I guess that's reality. These are real patients and people have the same kind of problems. There's not like a million different problems. So this particular person, carbohydrate metabolism or glycolysis is working well. Fatty acids, there's a little bit of a block. One of the markers is in the yellow, okay, but not as bad as the last one. We had the 2 markers in the red. So you probably wouldn't need to bring up the carnitine dosages so high. Probably wouldn't need quite as much vitamin B2. If you remember the first case we looked at, the citric acid cycle had 4 or 5 markers off. The second case had 1 marker off. This case has 2. So it's kind of in between. First one had a lot of citric acid cycle problems. Second one, a little bit. This one, it's a little bit more. So again, you can vary your dose of the multivitamin for the mitochondria based on, how many of these markers are positive and how tired or metabolically dysfunctional is the person. So your dosing can meet, with the labs depending, and you have a lot of flexibility in there. And this person, like the last person, has high lipid peroxide. So there's damage or oxidation occurring to the lipids or fats. So again, the program would be a little bit of carnitine, like we've seen. You don't need any support for glycolysis there. A little bit of the multivitamin for the mitochondria, right? And then a little bit of the antioxidants. Very similar to the last case. And again, if I was giving, general ideas on how these programs can be effective, you look at the patient, you decide how severe the problems are in terms of what they're experiencing in their own life in terms of symptoms. You look at the labs and you see, are there 2 markers here? Are there 1? Is there 4? Are there 5? How bad do the labs really look? And then you come up with, looking at the ranges of the various supplements that you can use, a coherent program that's going to address these metabolic problems. And I'd say there's 2 big issues that I see that I think are worth talking about. One is that we as a profession tend to underdose people. And so you see a lab that's a bloody nightmare, like the last one that had the 2 red markers here, and you give them 500 milligrams of carnitine. It's just not enough to make a difference. And the other problem that I see that's very common in program design is that people are using too many products. That's why something like combination products for the citric acid cycle are so convenient, because it's all in one capsule. You just tell them how many of that capsule to take each day. It's a lot easier than opening up separate bottles of 5 or 6 different things. So the 2 elements of program design, and I see this with the mentorship students. I watch this happen over the year that they are in class because they submit their programs to class every week, and I can see, wow, you've been in this class 6 months, you totally got this. But the things that they get are, number 1, how to design a program that's clinically impactful, that's got therapeutic dosages. So when you have, somebody with a massive problem with beta oxidation, like this patient here, remember, these both are in the red. When you have a problem that's that major, you don't give 500 milligrams of carnitine and hope it works. You start at 2,500 milligrams and go up if you need to get a clinical effect, so that you're targeting the right things with the right dosages, and that you're elegant enough and sophisticated enough with how you can look at the supplement catalogs that you can pick out combination products, like combination antioxidants that are super potent, so you don't need to take too many pills. Combination mitochondrial support products that are super potent, so you don't need to take so many pills. So you have a very small number of actual bottles of things on the shelf, but each dose is impactful and designed for an extra special purpose. And what often happens, I'll say this one more time, then I'll just be quiet and go away and leave you alone, is that doctors underdose, and I've done this myself my whole career. I spent decades, people, giving 500 milligrams of arginine twice a day and thinking that no one was getting better and that this whole thing with ammonia detoxification and arginine helping with nitric oxide was just not true. Not realizing I needed to start at 3,000 milligrams a day and go up from there to get a therapeutic effect. I just didn't know that. Nobody told me that. So you want to find senior clinicians who've been doing this for a while, or read a lot of books, look at research studies, and find out what are generally considered therapeutic dosages. And start with a therapeutic dose, right? And keep the number of products to an absolute minimum. If you can do those two things, you'll have doable patient programs that are clinically effective. And when patients feel a lot better and the program's not so overwhelming, they'll stick with it. Final thought. I know I said I was going to be quiet, but one more final thought, because this is like the most important thing I can say, is that what you will learn on your first NutriVal about your patient pales in significance to what you will learn about the patient from a follow-up test. So if you're bothering to take the time and energy of yourself and your patient's money to do a single NutriVal, you have to retest them in 6 months. That is, in my mind, not an optional thing. You do a program for 3 to 6 months based on the first test, and then you retest. And you will learn so much more on the retest than you learned on the first test. And it's a critically important part about being successful, having patient compliance, keeping patients in your practice for a long period of time. All right, so I'm going to wrap it up there. And again, I want to thank Genova for hosting our session, and I look forward to speaking with you at a future webinar. Thanks. Oh, hey, I'm back again. I know you thought you got rid of me, but I forgot. One of my staff just kicked me under the table in my leg and said, hey, I forgot to mention, we have this cardiometabolic health thing coming up. We saved 5 spots for Genova clients, customers. You get 20% discount with a Genova discount. If you missed the beginning of the webinar anyhow, this is super important. If you're interested in this work and you want to do a deep dive and spend a couple months really getting into this work, come check out the Cardiometabolic Health Bootcamp. It started this week. However, the first class was just an orientation call. You haven't missed anything yet. So if you're interested in signing up, you still have some time, and I hope to talk to some of you in that class as well. Okay, have a great day. I promise I'm done now. We'll talk to you next time. Bye for now.